lecture and hands-on. So we are gonna publish all the videos to YouTube. Probably, I don't know, like maybe we can change our plan, but the site-wise. But anyway, we are gonna publish all the lecture and hands-on, and then it will be publicly available. So, okay, let's double check. So this is the folder what we provide you, the data and installation, and then like whole 3 HTML file. Can you hear me, or do you want me to use the mic? But anyway, I will try to stay this way. So here, if you click the README, if you have an internet connection, you can access this Etherpad. So Roland already mentioned this one. So I want to use there more actively. I really like this one because it's, we can hear your status or opinion what we can cover it. So here already Roland mentioned some people ask already question and Roland already answers the questions. And I want to use this one for another activity for tomorrow 8 a.m. If people want to come here, if you just make a memo here, what kind of things you want to do more. Like for example, you want to review some topic what we covered today. Just I want to review this, or I want to do more like our markdown tomorrow morning, 1 hour. Or if you have some different topics you want to listen, you can just make a memo, and then we are gonna look at it, and then let's try to do something like make use our 1 hour more effectively tomorrow morning. So here is so that's why I just want to point this on again, and let's open, and then this one is what we already provide. This is the HTML file what we are gonna cover it. So here. This is actually made by the R Markdown, what we practice. So if you look at the more detail, you can make a really nice the documentation for this one. So I will cover for Bayes statistic part. So if I click, it will go to the the Bayes statistic part. Okay. Then let's start RStudio. Let's open RStudio. So probably your the 4-channel order probably maybe difference, but this is the one actually Roland used. So I will just want to use at this settings. Okay. Here, let's go to the RStat what we prepared, and let's go to the data. So everyone is okay. So if you have any trouble during any section, please put the orange one, and it's really help to like people have to know who has a problem or something. So we have a 4 file, and let's click this one. Click iprg.rda, and it says confirm rolled R data. So yes, I want to roll this data to R. Okay, and yes. So there, I didn't type anything, but I just click, and then they automatically just run something. And then let's check the environment. Now we have iprg data. Okay, so far? So now RStudio have our iprg data, and then we can work with this. Okay? Then what I will talk about this first is the randomizations. So yesterday, Olga mentioned about the design of experimental design, like how to randomize, how to replication we have to set up, and then how much we need of blocking. So 3 basic principles of experimental design. And then here, I want to show, especially for randomization and blocking, how we can use in R for your experiment. Okay. So here I use the IPRG data just to remind you what kind of data, what the experiment design look like. Here it is. We have 12 MS run, but each one actually came from one of 4 different conditions, and then we repeat 3 times. For example, here we have some sample from condition 1, and we measure, and then we have a different MS run name, and then we repeat it, repeat measured. So technically, this is a replicate. However, MS run name is different. The other one is same, right? And so on. So now we have a 3 technical replicate here. And for condition 2, here we also have a 3 technical replicate. So total, we have a 12 MS run. Okay, so we have a 4 condition. We are going to measure 3 times, and then we have a total 12 MS run. First problem is how we can make the order among this total 12. So for that one, let's start with the very basic things. How we can randomize, how we can sample it. So let's try to learn the function named samples. So sample is also another function to help sampling. So here, if I put the 10 and 1, means we have 10 numbers, and then we are gonna sample. We are gonna take 1 samples, okay? And then they choose number 9. Yeah, everyone is have a different numbers. Everyone is different number. I will try it one more time. Same things, different, right? Now we have a different, right? Because it's also randomized. So every time they have a different seed, which means where we have to start it, and then they're gonna randomize different numbers. Okay, from number 10, we want to select 5 samples. Then what we can change, here is 5. Okay, here they select the 5, number 5. And then I just try one more time, they select the different numbers. Then, okay, we have a 10 sample, and then we want to randomize these numbers. Means we are gonna take those 10 sample from 10, but it's really matter when we select the first and second and so on. So here, what we can do is 10 and 10. Among 10 number, we are gonna select 10 numbers. Here is we are gonna not repeat the sampling. So let's see. Now we have an order: 1, 9, 8, 5, 2, 3, 6, 7, 10, 4. Okay. So let's check what actually sample function have on other options. So here, now you can see sample function need x value, what kind of population we have, and then size, how big sample size do you want, and then here default is replace is false, means if you select some sample, they're gonna take that sample again. They just keep it, and then just select among the rest of the samples, right? Then let's try to make a different option. If I put replace is true, means even though first I select 5, next time 5 we can select the 5 again, right? So let's try this. Here they select the 7, 1, 2, 3, 4 times. Okay. So far so good. Okay. Then when I try the sample multiple times, their order is different, right? Means I just tried sample, and then I already got the order. However, I forgot this order. I want to get the same order as much as you can win, even though we repeat it. Then what we can do is set seed and put any number, whatever you want. Any number, whatever you want mind. Yes, and set and doing the same things. Okay. Then set the same number, and then if you're sampling again, now we have the same numbers. Means we are setting some starting point. If you have a same starting point, we can get the same samplings.
So what does 56 do?
It doesn't matter, whatever you want, any number. Why it is important means when we save the R script, for example, one day I said, okay, today is 2017 and May 4th, I want to set it. So set, I just use the set seed, whatever, this number, and then I got sample 10, and I got these numbers, and then I save this R script somewhere else, and then like 2 or 3 days after, when I come back, if I run this number, the same thing, we are gonna get the same sample orders.
It's kind of a set point for repeatability.
Yes, yeah. It's okay. So sometimes we use this one for our some extra task. So for example, you don't need to type it, just fun activity. So I will make some vector to include our group members' name in our groups. So I just put my name over here instead of numbers. And then Ting is there. Sarah is there. Dan is there. Cyril is there. And let's put Olga here. Okay. And run. And now group member vector has our 6 members' name, and we want to select 2 people who should come to the office at 7 a.m. next morning. So nobody don't want to do this, so we just want to randomly select. So now we have a group members, and what we can do is we want to sampling from our group member. What number of the member we need, we want to select 2 members from here. It's a really important point, So let's run. Sarah and Ting should come here, 7 a.m. next, tomorrow morning. So that kind of thing is what we actually can use it. It's just for fun. But okay, so now we understand that one. Let's try to make a mass back order from our data set. So now we have IPRG data, so let's check head IPRG and run. So it showed the first 6 rows, so I just want to review it, what kind of the information this one have. So IPRG have a protein name, right? And for each protein name, there are 12 MS run value are there, and for each run they have log 2 intensity and intensity value. So basically for same run, this value is log 2 of these intensity values. And from here what we want to do is I want to get unique MS run informations. So we practice the unique functions, right? Let's try to run, and it shows 2, 4, 6, 8, 10, 12 MS run information, right? Each one means the first MS run came from first sample and then this is B technical replicated, and so on. So there are total 12 unique informations. And then I want to make an order because based on this one, if you remember about the the principle of the experiment design, okay, if we can measure only 3 MS run a day, and if we are randomized, we are just measured by this order, let's see what can happen. So day first, we can measure condition 1, 2, 3 condition, and day 2, we can measure only 3 MS run with condition 2. Day 3, we can measure only condition 3 sample, and day 4, we can measure only condition 4 samples. Means when you want to compare the condition information already bias the day, because if something happened between day 1 and day 2, actually even though they have some difference, we cannot tell this is really condition 1 and condition 2 difference, or day 1 and day 2 effect. Actually, it's really commonly happen. Sometimes you have to change the column, or there's something happen like just between the day. So that's why we don't want to. So we want to randomize this order. Basically, we want to randomize this run. So what we can do here, let's keep this information like here. MS run will have unique IPRG run informations, right? Now MS run have this one, and then we want to make a random order. Use sample functions. Sample among MS run, and we can type 12 because we know there are 12 MS run. However, we can also check, put another function, MS run. Then let's check. Here, 3C first, 1A next, and 2B and 3B and so on, right? Let's try it one more time, and then they will show you another different MS run orders. Okay, so I will give you the very small practice. So if you have time first, I have a time point 0 measurement, I have a time point 1 measurement, I have time point 2 measurement, but I repeat 3 times. So basically I have T01, T02, T03, and T11, T12, T13, 2, 1. So I prepare the 9 samples, and then I want to make an order. Could you make our code for this one? I will give you the 5 minutes for this practice. It's not different. Yeah, the same thing.
So when you put the head IPRT, why
So here was, this one was the cheat sheet. So I just assigned this experiment like this way, but now I just continue to add the rest of information for this new experiment. Okay, so let me check. So I put the correct information, and always I just check they have the correct information, means length, or they have any typo or and so on. So now we have a 6 information there, and then I want to randomize this one. So sample, new run, and 9, and then they just show me the order of the measurement what I have to do it. Okay. Okay, so this one is useful labor-free or SRM or DIA. However, if you have eye track, TMT data, it will be different because we also need to set the channels, right? They have a channel and then run information. That kind of experiment design is a more complicated level. We need a little bit more complicated coded. So this time I will not cover it, but if people are interested in, just let me know in the memo. Then let's try to, so here's the things, and then let's move on to Bayesian statistics summarization. So let's go back. So here, our start of Bayesian statistics. Okay, so first, I will use the IPRG data, but let's a little bit review what we did, this morning. Let's check how many unique protein ID in IPRG data. So unique information for IPRG and protein name. Okay, I run it, and then there are so many information there, and then they show until 1,000, and then they said there are more. There are 3,027 protein names are there. So I want to check head unique protein IPRG proteins, means they show the first 6 unique protein IDs. Okay, so among this more than 3,000 protein, I will work with only 1 proteins. Okay, this one can be confused. So if you can open this one, let's copy this line. Yes. Oops. This line. So here, guide, go to Bayesian statistic, calculate the simple statistics, and let's copy this line.
That one protein data, if it's, so what does that mean?
Yeah, I will explain this to you. If people succeed, copy this one to over there. Please put the green one. Yeah, if not, because this is really beginning point, so everyone should get this one. So then let's see here. This is for the font size is really big for me, but here IPRG. Under the IPRG, we have one protein data type. What does this mean is here from IPRG and then bracket. So we want to get the subtract data. What kind of subtract data? IPRG protein data information is equal to this specific protein we want to get it. Okay. Then let's click this one protein data here under the environment. If you click this, if you click the one protein data, it will show you how data look like. Okay, let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 12 rows, and you can see all the protein name is same, and the run name is different. So for this specific proteins, there are intensity value for 12 MS runs. Okay? Okay so far?
So if you want to write data for two proteins, you will type two protein data?
Yes. If you want to type the two protein, it's okay. Let's try to do this. It's okay. IPRG. If you want to more than two, I will recommend okay, I will explain this. Okay. From IPRG, I want to get subset data, but based on comma, I will separate it, right? But I want to subtract the okay. So here's a row. I want to subset of rows, right? And then what kind of row? I need to put the add the information, which is a sum of the function too. From IPRG, proteins information include and include, we have a more than two, so we have to use the vector, right? So I want to type the vector. Vector is always from C, right? Yeah. Then this case protein name is really complicated. So let's copy just the first two. Just copy just first two protein name. And just next to this one, but you have to make a quotation mark. Okay. I copied just first two protein names here. And I run it, and now you can see I add this subset of the data to the two variable, and then now here you can see one protein have a 12 observations, but two have a 24 observations, 24 measurements, right? So one protein for 12, another protein is for 12, so now total 24 observation rows basically. Okay. Then with this, let's calculate the mean first. So another new functions. I want to show aggregate. Aggregate means this is the what we are working for. We are gonna aggregate means we are gonna separate by whatever you want. Separate this data set by condition and then summarize it. okay? But we need to decide by what we need to aggregate it. So for example, here, I want to saved sub means I want to aggregate the data, which data from one protein data, and I want by aggregate by condition, and I want to aggregate by these functions, by mean. But exactly what measurement I want to use is log2 intensity. So here, we need to set up the three things: data, function, what do you want? How you can want to aggregate it. So here, data, we want to put what we want to here. Function, we want to calculate the mean. But if you go back to the here, I want to calculate the log intensity. I want to summarize log2 intensity by conditions. And how to summarize it is basically this fun. So fun means not make fun. This is just functions. Okay. So let's try to run. And what they have is look like this. Okay. So if just summarize again, this is our data, but we want to do something for log2 intensity by condition. So by condition 1, we in this case we want to calculate the mean. So calculate the mean of these three values, and calculate the mean of next three values, calculate the mean of three value, and so on. Let's try. This is the default one. Here is the activity. Short activity. Let's try the two things. Instead of the mean, let's calculate the median per each group, and let's try to calculate the standard deviation for each conditions. And here's the answer, but you have to modify the function what we practice. If anybody success to get the same number, let's put the green stickers over there. You want to go back to this one? So So, so I put the whatever the result to the sub means. Let's make another data include the standard deviation, and let's make another data with the median values. Yes. So let's try to do this. It's really similar. It will be really minor one. So I will copy this one. And only two things I need want to change. Instead of the mean, I will change the variable name. I will save the sub median. Same thing. However, function have to be changed. Instead of the mean, I put the median. Okay. Then let's check some median. If we want to compare these two values, a little bit difference, right? A little bit difference. The next step was, what was it? So let's calculate the standard deviations. So two things again, I will change this one, standard deviations, and then I will change this is the standard deviation. So we have a very basic function, mean, median, standard deviation. What we talk about just before this one, we talk about the standard error, standard deviation, standard error, and confidence interval. There are very simple functions as standard for SD, standard deviation, but there's no function for standard error and confidence interval. That one we actually have to calculate it. Okay, so here is.
How do we know which function name?
So that is what actually we practiced this morning. So here, if you're searching something like standard deviation, they show so what kind of any function include like some standard deviation. So here stat is always show the package name, but this one you don't need to worry about it. This one is default function in R. Whenever you install the R, there will be there. So this package have a standard deviation. You can see standard deviation. You can use this function. Okay. If this is a simple one, but if you want to more complicated cases, you can search in Google. Yeah. So let's try to calculate the standard error for this case. If you remember, maybe it's also always confused. This is the equations. This is the equations. So basically, we need to write the equations. So before this, let's practice very simple case. I want to calculate this one in R. How can I do it? Is you have to make just one line, just this equation. So to calculate this, we can write it down. 2 to the 3 divided by 5, right? To this, in computer, we can say 2 to the power 3 and divided by 5, right? This one, we use this slash in computers. So to calculate this, we basically can type 3 divided by 5, right? We can calculate it, right? This one, we know this one should be square root of 2 divided by 5 times 2. We don't know how to do this one, right? This one, they have a sum function square, so we can use that one. So how to do it? Square 2 divided by 5 times the 2. So we can calculate, we can write down just one line. Okay? Then if you go back to the standard error, to calculate the standard error, we need to know standard deviation and we need to know n numbers. Then we can write it down, right? So while we actually we calculate the standard deviation for our one protein data. And then we also need this information. N means how many we have. Basically, we can use function length. Okay. So what I can do here is also same functions. So here I want to calculate the n. What function I want to use length. Okay. Then if I run sub n count length, our end, right? Everyone is okay so far?
What is it sub dot n? What does it mean?
N is a sample size. How many measurements we have? So, for example, here, our case, to calculate the standard error, we need the standard, for example, for condition 1, we have 3 numbers. We calculate the standard deviation among 3 numbers and divide by n. How many measurements we have? 3. That is what we are now to calculate it. Everyone is okay so far? Okay, then let's calculate the standard error. So for standard error, we need to use standard deviation and error. How we can do it? Basically, the equation was square root variance divided by n, right? Means we want to square s squared divided by n, right? Just we can write it down. This one is just like this. So square first, right? Within the parentheses, we need to calculate sub SD log 2 intensity to the 2. This is this part, right? And divide by sub n to log 2 intensity. Then this is our standard error.
When you did this, why you don't have aggregate again, aggregate function here in the class name?
Aggregate if you want to do aggregate, we need to find the function here, right? Within the data set. Within the data set, we can write this kind of function here, but yeah, this is just one of the way we can do it. Okay. Everyone can calculate this one. Let's go back to let's double check the sub SD. What we have here is the standard deviation what we calculated, right? So we want these four numbers. These four numbers came from sub SD and log 2 intensity columns, right? And divided by sub n is this one. Sub n, the log 2 intensity column will be the length of our measurement, right? So now we have a sub n SD. So now we have like some multiple variable we calculated, but let's make a nice data set only for summarized one. Okay, so here I will make a new variable include only summarized one. I will make a data frame, one of the, so I want to make a data frame. I will ready to make a new data frame. And we need to define the column by column. So let's make first column have information is group. What kind of group we want? Condition 1, condition 2, so group information we want 1 to 4. This is the first column. Let's try this one first. Then summary result have first column with the group information 1, 2, 3, 4. Okay. So here, this is the vector, right? And data frame is want to make a matrix one. So for example, if you think about the data, so here we have a vector. So for example, now we have a group. This one have 1, 2, 3, 4. This is the vector. If you make a data frame, this vector go to this one, okay? And this one will be the column name, okay? So here, this column name will be group, and then this order will go to 1, 2, 3, 4, okay? Why we need it? We want to make this one is extend. We want more columns. So then we have a group here, and then we have a mean value for each group. 10, 11, 12, 13. And then we want to merge these two information as one data frame. And then this one go to the first column. 1, 2, 3, 4. And then this one go to the another column. Mean. 10, 11, 12, 13. We can merge this information just as one data frame. Okay. If we have one other one, we can also add this one and so on. So here is the what I show you. So first we put the group information. However, let's add one more. So summary result data frame summary result. So now we already have one data frame, but we want to add. Oops, sorry. We want to add another column just next to there. Summary result data frame summary result, and just next to there we want to add the mean value what we calculated. Mean is what we get from the aggregate functions. Okay. Yeah. If I run it, now we have two columns. So we can add just next to group information what is the mean for each group. Okay. Then let's add another one. Standard deviation and standard error. And length. Yes. So, yes.
Yeah, so can you scroll up? So when you use the two conditions, now you write condition 1, condition 2, and then you have C1, C2, C3, C4.
Yeah.
I was kind of lost. I got the results here, but I just cannot go back there.
Yeah. Yeah, that one is I just typo. I just yeah. So we need the C1 to C4 because we have 4 different conditions.
Right.
Yes.
So how does it read? Because it's in the file is condition 1, right? It's written both things, but here now put it C1.
Oh, you can type the condition 1 fully, but like just minimize the typo. I just the C1, C2, C3, C4. So everyone get the summary tables? No. Could you put the red, orange one?
So R does I mean it reads both condition 1 and C1 as same.
No, I just type it. I type it. Yeah.
So with the So can't we do all these calculations in one step and one function rather than doing it twice?
Yes, but to demonstrate, she did it in multiple steps. So she shows you, okay, here's data frame and rows. If you would write it in your script without needing to demonstrate, you would call data frame walks with group, mean, SD, SE, and max.
So how do you add adding functions like one and different one, or how does it add? In one step, if I add standard deviation, mean, standard error.
No, you would still calculate these soft.se, sorry, soft.sds, soft.n independently. But when you create data frame, you would not call data frame 3 times. You would just say data frame once, and then you would specify all the columns. Group, mean, SE, SE.
So we want to concatenate all these layers of calculations together.
Oh, using aggregate.
Oh, can you do it?
I no. Maybe there is a way, but it would be soft.mean is a data frame. First call is position, the second call is intensity. The name is weird. It's not dot intensity, it's the mean of the two intensities. But SE was not created like we created the other ones, but on aggregate. Soft.SE was created by calculating the square root of the vector.
I didn't see
This
the
is
one.
soft.SE.
I added the last.
Divided by not a vector. They all have vector form, so soft.SE is already a vector. All the other ones, yeah, so see, this is data. So I don't need to say
Why? This is a vector versus
yeah, you see, soft.SE is a data vector, so it says that's
because I understand why the
soft.SE. That one.
Then I assume everyone have a summary result tables. Okay, let's here's the summary result tables. Okay, let's assume from your data you have these summary values, and then we are gonna plot it with the ggplot. So just in case if people not wrote ggplot, let's try to call the ggplot2 first, library and ggplot2, and we are ready to use it. Okay, so I put the ggplot. I will draw the ggplot. X value should be our group. Y value, I want to plot mean values, and I want to make different color by group. Okay, all this information from data summary result.
So right now, the summary result is a data frame, right?
Yes. The summary result is this, not original data, this is just summarized data, include mean, standard, deviation, standard error, and so on. Okay. If we enter, nothing happened. It's just we are ready to do it. Just ready to plot it. Okay. And then P has this ggplot. Let's add to P. I want to draw point plot. I just want to make a point for each mean. So here, geom point then we have it, this one. Everyone get this one? Everyone get this plot? So yeah, here, just next to file, you can see this one, right? Okay, I will try to add a little bit of data. So just next to here, I want to make a bigger dot. I want bigger dot. So size can control the dot, size of dot. So let's try do this. Let's look at this, how it changes. Ready? Can you see the size difference? Yeah. We can do this. And let's try to add a little bit different things. So P, same thing, P plus point size 3 and plug here, and I don't want to really long, just one line, then you can enter it here. Then I want to add the labels. Main labels, change the x label, x-axis label, and y-axis label. So this one is from lefts. Okay. I want to change the title. This is me. Okay. And I also want to change x-axis label. X-axis should be, here I have a group, but I want to say this is conditions. Okay. I also want to change the y-axis. Here, currently we have the mean for labeling for y-axis, but I want to change this one. It's a log to intensity. Okay. Then let's try to run.
So you have somewhere like 2 ports, somewhere single. Is it okay?
Yeah, it's okay. It's okay. Yeah. So now you can see here. Now y-axis label and x-axis, and now we have a title here. Okay. And I want to add one more thing. I don't like this gray background. I want to make this is white. Okay. So at the end of this line, plus and enter. I changed theme of plot. So B double means black and white. I want the background is make black and white. Okay. And then I click run.
So what if color?
Mm-hmm.
What if you make a color?
How we can make a color different? Yeah, background. So this is also another very specific function. Make a background is black and white. However, there are also multiple ways you can change the color everywhere. Yeah. Okay. And if you see the HTML1, I also changed where we want to put this one. This label, we can put the top or bottom, and so on. All the sizes and so on, we can change it. But next one, what I want to do is I want to add the error bar. So here, P plus, I want to make a point there, and over there, I want to add error bar.
So is the same line continue or is it
Different. I made some lines difference. So there's also function to make easy to draw the error bar. Here, error bar. To make an error bar, we need to assign from where to where. So we need to assign which one should be top maximum value and which one should be the minimum values, right? So at this moment we need to type it here. So here, y max value should be mean plus standard deviations. Okay. Then y minimum value should be mean minus standard deviations. Okay, so here's the mean value, but error bar will be draw mean plus standard deviation to the mean minus standard deviation. Okay. And just after this parenthesis, I set the width of error bar. the error bar size, how large error bar we want to draw it. And let's put this one to another, like for example, Q.
Why is that?
Just you can choose any variable numbers. So here, our run. What is the problem? Oh, yes. So here, then what is a Q look like? Here, can you see? There's a dot, and then they overwrite error bar here. So this one have this red and blue one relatively very small error bar, and this one you can see they are really wide error bar there for standard deviation. Okay. And now I want to add error bar with the standard error, not standard deviations. Okay. Why should I change it? Sorry? Yes. So I will just copy here, maybe Q2. Instead of standard deviation, I just change this one is standard error. Okay. And then standard error. Okay. And let's change this size. It's really hard to see how much we have error bar. I will change this one is 1.5. And then I will run. And then save it to the Q2. See the Q2. So let's compare this one. So for example, let's go back to the Q case. I also want to make the same size to compare standard deviation and standard error. So I also change this one 1.5. So let's run this again. See, this one is a standard error, and this one is standard deviations. Let's try to do again. So Q is with the standard deviation. Q2 is standard error. Can you see the difference? So Q is this much, and then Q2 is this much. So standard error is narrower than the standard deviation, right? Okay. Then this is the last one. Let's try to make a confident interval. Okay, so if you go back to our HTML1, almost at the end, calculate the confident interval. Let's check this one. And here is the calculation, how we can get this confident interval. We have to calculate it. We have a mean, we have a standard error, and then this is the equations. So for example, we have a standard error value. However, we need to calculate this part. So I think this is already overwhelming today. So probably if you want to, how we exactly calculate this part, I will talk about this one probably tomorrow morning. But let's just copy this one. Let's just copy this. And let's try to run all together. So now summary result table they have two more extra column for lower level of confidence intervals and the upper level of the confidence intervals. Okay. So with this, we also can try to make a figures. We can change something. So let's copy this. And let's change this one, Q3, to make a different error bar. What I have to change is the error bar with the confidence interval. What we have to change this one. So if you want to change the error bar, definitely we need to change this part. So here, y-axis value, y minimum value, and then width. So confidence interval, we have a different mean, and their mean and maximum value have to be changed from what we calculate here. Lower level and upper level. Upper level should be y maximum value, and then lower level should be y minimum values. Right? So here, let's change. Instead of this, let's try the column name. The maximum should be upper one, and minimum value should be the lower level one. Okay. Then I run. Let's try to draw the what it looked like with the confidence interval. Okay, so I need to P again. I need to generate the P again because this one is from P, but I add this one from original one. So I rerun the P value, a P variable, and run this, and Q. Now we have this one with the confidence intervals. So let's review again. Q is with the standard deviation. Q2 is with the standard error, is narrow, and then Q3 with the confidence interval is really wider. Okay. That is just basic practice, but HTML they have more examples and challenges. So let's save just last figure in our folder. Just review what we learned, how to save it. PDF file, open, mean, width, confidence interval, PDF, and let's set our width or height too. There's also options for no, so size inch, 4 inches, 4 inches. So let's just start a PDF and then draw the Q3 in the PDF and then finish it. Device this should be off. Then our folder under whatever your working directory, now you can find the mean with the confidence interval, PDF files. If I click it, now we have a PDF file for this plot. Okay. So I think we are done for our materials, but there's more detail and challenges in HTML1. And our regular schedule is up to 5 p.m., but we have extra practice. It's really also optional. So you can play with what we have, or if you have a question, just you can raise your hand, and if you have internet connections, you can also type it here about your questions. So if people want to review another one or do something else, we can practice here up to 6 p.m. Okay. Thank you. And then also tomorrow 8 a.m. is also optionals, but regular time start with the 9 p.m. But in the schedule we will start with the practice hands-on section at 9. But we changed our schedule, so 8 a.m. Olga's lecture will be started. Then after that we are gonna hold day will be the hands-on section, just practice. So 9 a.m. lectures, Olga's lectures, and from 11 we are gonna do our hands-on one. Yeah. Okay, thank you. And then please take a rest as much as you can. Yeah. And then tomorrow we'll have a more energy.
Make sure the PDF
Yes.
make sure how to write into PDF.
This one?